So I'm going to do a quick chemistry review for our final tomorrow. It'll be very rushed. So bear with me. Here we have the periodic table, okay? I'm going to quickly go through some of the things that I put down in this table. So again, we are going to be probably asked to draw the two different ways of drawing here, an element. Here we have the Lewis structure, and we have the other electron dot structure. In this one, starting with the Lewis structure, we notice that in order to do this, you have to use valence electrons. The valence electrons are the group numbers, which you found in the table. So I have written them above right here, starting with 1, 2, 3, 4, 5, 6, 7, 8. So you're going to use these numbers, or the group numbers, again, to find how many dots you're going to have here, right here. So here for chlorine, as depicted here, you have 7 electrons, 7 valence electrons. So therefore, you're going to write 1, 2, 3, 4, 5, 6, 7 valence electrons. Now here, for sodium, you're going to use the protons of the whatever element you're dealing with. So here we're dealing with sodium right here, and we notice that it has 11. So therefore, we're going to write 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, when it comes to the orbits, you should remember that the first orbit has 2, the second one has 8, the 3 can hold up to 18, the 4 can hold up to 32, etc. But you're likely only going to have to know up to 18, which is the third orbit, or maybe even more than that. But yeah, 2, 8, 18, 32. Now when it comes to the charges, you should remember that hydrogen, starting with here, you're going to have a +1, +2, +3. This one's going to be empty. Then you have -3, -2, -1. And keep in mind that these charges are going to be used when it comes to drawing the kind of, when you're given a compound or any kind of thing, so you have to find the elements, you're going to be using these different charges for that purpose. Let's see what else. Also, when they're giving you like a pair of elements and they're trying to tell you, they're asking you whether they're ionic, from an ionic molecule or compound, you should remember that this only happens when you must have a metal and a non-metal in order to have an ionic bond. Also, don't forget when it comes to writing the full electron configuration, that here you have this is the S, so these are kind of the block S. Here you have here below you have the block F, as I put right here. This is the block D, and this is the block P. So the reason why you're going to need this is because when you're drawing your electron configuration, especially if you're doing shorthand, let's say we are probably trying to find silicon. So silicon is located right here. So to find the shorthand configuration of silicon, we would look at here the noble gases. So our noble gases are in group 8, which is the very last column of their periodic table. So we look at here, we notice that in silicon, we look at the same row right here. And you look one element above in the noble gas. So for silicon, it will be neon. If you were looking for, let's say, nitrogen, it would be helium. If you were looking at something different, like lead, then it would be xenon right here. So since we are looking for silicon, we're going to put silicon right here. It's neon, right? So you're going to put neon in brackets right here. And then what you're going to do is you're going to go to the beginning of the periodic table. So you start here, you count down. This is 1s, 2s, 3s. Silicon, as you can see, is in 3s. So write 3s, and then you're also going to end up writing how many of these are. So we are covering both of these, 1 and 2. You're covering the first 2s levels. So 3s, 2. Then you're going to move to the next block. So you're moving from block to block until you get to that element, to the block D, where you are going to you're going to skip this block. You're moving directly to the block, to the different block, which is P. So here in the P block, you're going to find silicon. Again, this here, it tells us that silicon is located in 1, 2, let's see. So 3P, because here it starts at 2P. Don't forget this. It starts at 2P. So remember yourself that there's a little weird order when it comes to the elements. Like helium is kind of weird because helium is not 1P, but it's 1s. So 2P starts right here at neon, right here. So you start 2P when you have 2s here. So then silicon right here would be 3P. So 3P, and then once you find which P level is it, you count from here, just from this block. 1, 2. So it'll actually end up being 3P2. 3P2. Now if you're a little bit confused on that, I'm going to go ahead and do another element. So fluorine. Fluorine is the symbol F. Let's see if I can find that anywhere here. Okay. So it should be somewhere here. Okay, here. So fluorine is right here. So first you draw the symbol, then in brackets, again, like I said, you're going to put that noble gas that is right above. So that would be helium. Right after you have helium, you come back right here to the S level. So here you don't have 3 because you're in the second. So 1, 2, 2s fluorine. So 2s2 because again you gotta count this 2. Then you move to the P level because this is what you're dealing with. If you were dealing with this level, then you would deal with the D, but not this time you're not. So again, you're now at the P. So again, fluorine isn't 2p as clearly as it is right here. So you draw 2p and you count again. 1, 2, 3, 4, 5. So in this case, you're gonna have 2p, 5. That's how you do shorthand configuration.